Hello everyone, for this tutorial video, I'd like to explain basic properties of multivariable functions, starting with questions about their domain. If we are given this function and asked to find its domain, we would see it would be valid if the square root is greater than or equal to 0, which means in turn, x plus y must be greater than or equal to 0. So this means we have a linear inequality rather than a flat inequality like if we had x's alone. If we instead had square root of x plus square root of y individually, we would see that x would have to be greater than or equal to 0 and y would have to be greater than or equal to 0 at the same time. So the graph of the domain would look more like this. If we wanted to figure out the domain of this function, we see it is valid only when the argument of ln is greater than 0. And we next do some rearranging to get the equation of an ellipse, with a horizontal radius of 3 and a vertical radius of 1. And we see, because we are told it is less than 1, this means the domain has to be all inside the ellipse, except at the edges, as indicated by this graph. Now that we have figured out how domains work for multivariable functions, we can discuss graphing multivariable functions in 3D next. In particular, if we are told this is the function, then we would see that z is a constant at an arbitrary value k, and at any arbitrary value k, z would be defined as a circle in terms of x and y, where the radius of the circle gets smaller the closer you are to z equals 0. So it forms a drill shape like so. The final concept related to multivariable functions is level surfaces, or the intersection between a plane and a surface of the function. In particular, if we are given two planes, one with a specific value of x and one with a specific value of y, we plug in x equals 1 for the plane of x equals 1 and simplify the function. To notice, it is now a parabola with respect to y, which makes sense if we look at the function and the plane intersecting it. By the same exact logic, we'd substitute in y equals 2 for the other plane, and see it simplifies to a parabola with respect to x, which again makes sense from the graph, because it looks like a 3D version of a parabola, so it should form a parabola shape when planes intersect it from different angles. Now that we have figured out basics of how multivariable functions work, we can discuss how vector functions work next, which are multivariable functions all expressed in terms of vectors rather than scalars. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.